3.5, derivatives of trig functions. So the first thing I'm going to do is use the definition of a derivative to find the derivative of sine of x. You won't need to do this because I'm just going to tell you what they are, but it is kind of cool to see it derived. So find the derivative of sine of x. So we use the definite, what in the...
What's that?
I literally was writing it side by side and it moved it.
Oh.
Use the definition of a derivative. So dy dx, and I'm not going to write this all the way down, I'm just going to write it once and then go from there, is equal to the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. And so, in your mind, you might be thinking, how in the world are we going to cancel something? Because obviously we know that's what we need to do to get rid of h. Well, I'm glad you asked. So, we are going to have the limit as h approaches 0 of, when we have the sum of two angles, k with sine, that will break into sine of x cosine of h plus cosine x sine h minus the sine of x all over h. And this was because of the angle sum identity, which is also known as when we did like the sum of like the angles in the trig functions. So if I combine this sine of x and this sine of x cosine of h, I can take a sine of x out of those things. So I'm kind of reordering it and taking something out. And so I'm going to have the limit as h approaches 0 of the sine of x times cosine of h is left in this part, and I'm just left with a 1 over here. So cosine of h minus 1 plus this cosine x sine h all over h. So then now I have the ability to break this up into separate limits, okay, which is what's going to allow me to do what I'm doing. So this is going to be the limit as h approaches 0 of the sine of x plus, or times the limit as h approaches 0 of cosine of h minus 1 over h. Okay, so basically I'm splitting this into two separate like fractions. Okay, the sine x times cosine h minus 1 over h plus cosine x sine h over h, and then I'm just splitting it up now within the limits. So then plus the limit, I don't have enough room, as h approaches 0 of cosine of x times the limit as h approaches 0. Oh dear. I'm going to get rid of this and move it over just so I have room. You don't need to erase anything. I'm just moving. So times the limit as h approaches 0 of sine of h over h. So there's no h in this piece, so this is just left as sine of x times, if I have 0 here, this is one of those weird ones that actually ends up being equal to 0. would be kind of one of those things that you would just know, basically. Plus, this one has no h's, so cosine of x times, this is a limit that we memorize, which is just 1. And so this is equal to, by the time this is all said and done, the cosine of x. So d dx of sine of x is equal to cosine of x. So the derivative of sine of x is cosine of x. So now, don't worry about actually being able to do what I just did. You don't need to worry about that. Just so you see that these aren't just pulled out of nowhere. These are, like, legitimately derived. But I wouldn't stress about that. So the trig derivatives of all 6 trig functions. d dx of sine of x, we just said, is cosine of x. d dx of cosine of x is negative sine of x. And d dx of tangent of x is equal to secant squared of x. Now, before I keep going with the other 3, what do you know about tangent? What's another way to rewrite tangent? Sine over cosine. So if you should happen to forget the derivative of tangent, you can easily derive it by using the quotient rule on sine of x over cosine of x. So pretty much with basically all of these, if you know sine x and cosine x, you can derive the others by the the quotient rule. Okay. So there's those ones. So then the other one's d dx of cosecant of x is minus cosecant of x times cotangent of x. d dx of secant of x is equal to secant of x, tangent of x, and d dx of cotangent of x is equal to minus cosecant squared of x. So cosecant, should you forget it, can be found by doing 1 over sine of x. Obviously, but the first part, you take the derivative of the top, that's 0. So it's going to be 0 minus the derivative of sine times 1. And so then all over sine squared. And so that's what reduces down to that, and so on and so forth with secant. It's 1 over cosine. And then cotangent would just be cosine over sine, and you could use the quotient rule on that. So if you forget it, as long as you know these 2, you can find the rest. And I often forget the other ones just because I don't use them as much, and I end up deriving them because it's just easier. All right, the last thing is something new. Well, not that that's not new, but it's called jerk. You're probably like, what in the world is that? It is the derivative of acceleration.
It's still weird.
It is.
It's very specific.
So this is the derivative of acceleration if a body's position at time t is s of t, the body's jerk at time t is j of t is equal to dA dt, also known as the third derivative of position. So if you take the derivative of position, we get
Velocity.
If we take the derivative of velocity, we get
Acceleration.
And now if we take the derivative of acceleration, we get
Jerk.
Yep. I was way less confident.
Yeah.
She was like,
It's just weird.
jerk. It gets used in word problems, basically. Not a whole lot otherwise. And basically, we're finding it at a certain point. And for some reason, a lot of times it ends up being 0. Anyways. Alright, that's what we are going to do for today. Use the rest of the time to do the homework that I assigned you yesterday. And then we'll do examples of this starting tomorrow.